Hello everybody, welcome into another lesson. So today we are going to continue with conic sections talking about hyperbolas this time. And here you have a hyperbola, which you can almost think of it like a double parabola, because that's basically what it looks like, is a double parabola. Well, like ellipses, hyperbolas have a major and a minor axis. Now, this is the equation for a hyperbola when the x-axis is the major axis. And for today's lesson, the center of these hyperbolas will be at the origin only. Now, in the next lesson, we'll do other centers that are not the origin, but for today, the centers will just be at the origin. So, the standard equation, if the x-axis is the major axis, you have x squared over a squared minus y squared over b squared equals 1. Much like in ellipses, the right-hand side always has to equal 1. You know, also hyperbolas, you can almost think of it as like you took an ellipse, you split it in half, and then you folded the sides over away from each other. That's almost what a hyperbola resembles. Now, let's see, so this is the x-axis is the major axis. If the x-axis is the major axis, that means the hyperbola is symmetric with the x-axis. So it's going to run along the x-axis. So you'll still have your center at 0, 0, but your vertices will be at that plus and minus a0. So you'll take your center and then you'll add plus and minus a to the center and you'll get the coordinates of your vertices. Now, we don't worry about any co-vertices for hyperbolas. However, the foci, we still have foci. This time the formula for finding the foci is c squared equals a squared plus b squared for hyperbolas. You find your value of c. Your foci, if the x-axis is the major axis, is going to be that plus or minus c plus 0. You have your foci out here. And then something else to consider too for hyperbolas, you're going to have two slant asymptotes. What those do are they guide the shape of your curve. So if the x-axis is the major axis, that means you could take that y squared over b squared set it equal to x squared over a squared, and then you just solve for y. You'll get y equals both plus and minus ba over x. And the asymptotes will travel through the center. And those asymptotes serve to guide your curves. So that's what those do. Now, let's flip this around a little bit here. Let's make the y-axis the major axis this time. Now, the asymptote should largely end up being the same for the example I'm about to do. For all intents and purposes, they will be. But we're going to make the y-axis the major axis this time. Alright, let me just fix this up here a minute. Alright, so this time, well, let me draw this hyperbola here first. All right. So this time we have a hyperbola where the y-axis is the major axis. So as you can see, if that's the case, the hyperbola goes up and down, and it's symmetric with the y-axis. So this is where the order of the variables does matter. So if the y-axis is the major axis, your y variable will always come first in the equation. You'll have y squared over a squared minus x squared over b squared equals 1. So the order of the variable does matter with hyperbolas. The center's still at 0, 0, but if the y-axis is the major axis, you'll keep your x-coordinate of 0 the same, and you'll add that plus and minus a to the y-coordinate of 0. You'll get your vertices at 0 plus or minus a, which we have right here. Finding the foci is still the same. You find your c, where c squared equals a squared plus b squared. So your foci would be 0 plus and minus c, which I've labeled here on the graph. And then again, you're going to have two slant asymptotes. So just set that y squared over a squared equal to x squared over b squared. Solve for y, you get y equals plus and minus a over b times x. And those slant asymptotes help to guide the shape of your curve. So let's go ahead and get started with some examples here. All right. Now, what do we got here? So we have x squared over 25 minus y squared over 121 equals 1. So we have x squared over 25 minus y squared over 121 equals 1. Well, the x variable comes first, so that tells you the x-axis is the major axis. So that helps right there. Now, let's establish the center of this hyperbola. Well, it's just going to be 0, 0 for today. The center is 0, 0. So let's go ahead and plot that center at 0, 0. Now, next thing we need to do, find the vertices. So that means a squared equals 25. So a equals plus and minus 5. So that means that your vertices, since the x-axis is the major axis, would be plus and minus 5, 0. So we can plot our vertices. Here is negative 5, 0. Here is positive 5, 0. Well, there's our vertices. It's going to be kind of hard to label all this when we have asymptotes and all that to worry about. But we found that. Now, we need to, I would actually say next let's find the asymptotes so we can get drawing those. So the asymptotes, you're going to take your y squared over 121, set that equal to your x squared over 25, which would then give you that y squared equals 121 over 25 x squared, which gives you your slant asymptotes at y equals plus and minus 11/5 x. So now we need to plot our asymptotes before we even attempt to draw the hyperbola. So let's see. At 0, it's 0. At 1, it's 11/5, so that would be 2 1/5 for your asymptote. We'll make a little dash right there. In fact, let's go up. At 2, it's going to be 22/5, so that would be 4 2/5. Just trying to get a good asymptote here. Okay, I think we kind of get the picture. See, -1, that'd be -11/5. If we're doing the plus 11/5 asymptote, that'd be -2 1/5. Okay, so I think we get a sufficient picture of what this asymptote's going to look like. For the first one, the plus 11/5 x, we also have to do the -11/5 x. So at -1, you would end up getting a y of positive 2 1/5. So it's going to look about like that. And then at +1, you would get -2 1/5. So basically, it's just finding your points and then drawing your asymptote lines through that. Now, I'm probably going to extend these a little bit just to help us with the sketch. Alright, we have sufficient points now to draw the hyperbola. This isn't the best exact representation, but that's about what it's going to look like. It's something like that, and then let's find the foci. So c squared equals a squared plus b squared, which would then equal 121 plus 120 plus 25, which would mean that would equal 146. So c would equal the square root of 146. So your foci are going to be at both plus and minus the square root of 146, 0. Which, let's find what the heck the square root of 146 is. Well, it's over 10, so it's going to be off the chart. Your foci are somewhere out here and somewhere out here. But that's roughly what the shape of this hyperbola is going to look like, with the center at 0, 0, and the x-axis being the major axis. And I got more. We have y squared over 49 minus x squared equals 1. So y squared over 49 minus x squared equals 1. Well, I think it's safe to say we have a denominator of 1 for your x squared, so that'll help you out a little bit. Alright, now, it's clear to see, since y is the first variable in this, that the y-axis is the major axis. So you have the y-axis is the major axis. Alright, now the center is at 0, 0, so that's going to help us. So let's go ahead and plot the center. That's at 0, 0. Now, what about... why don't we do our asymptotes? So asymptotes, you set that y squared over 49 equal to your x squared over 1, or simply x squared, that'll give you y squared equals 49x squared, giving you two slant asymptotes of y equals both plus and minus 7x. Those are your slant asymptotes. So let's graph that here. It's going to be a steep asymptote. Alright, so there's one asymptote. Then that was the plus 7x. We got to do the minus 7x. Dang it. Alright, so there's your asymptotes. Now, we also need to find the vertices. So that means a squared equals 49. So a would have to equal plus and minus 7. The y-axis is your major axis, so your vertices can be found at then 0, plus and minus 7. So let's plot our vertices. 7. There's one vertex at 7, 0. At 0, negative 7. 0, 7, 0, negative 7. Okay. Now let's find the foci. So c squared equals a squared plus b squared, which would end up equaling 49 plus 1, which means c squared equals 50. So c would equal plus and minus 5 times the square root of 2. So your foci, since the y-axis is the major axis, would be at 0 plus and minus 5 times the square root of 2. So let's plot the foci. It's about 7.07, so not far past the vertices. Not far past the vertices at all. Now that we have everything, we can draw the shape of these hyperbolas. So, with the asymptotes, you see the form it roughly takes. So your hyperbola would look roughly like this, with those slant asymptotes of plus and minus 7x, with the center at 0, 0, and the y-axis being the major axis. Alright, I got even more. Alright, so let's see. We have x squared over 49 minus y squared over 4 equals 1. So x squared over 49 minus y squared over 4 equals 1. Well, what's your major axis? The x variable comes first, so definitely the x-axis, right? So the x-axis is the major axis. Alright, so let's establish what the center is. That's 0, 0. The center is 0, 0, so that was easy. So let's plot our center at 0, 0. Now, let's go ahead and figure out our asymptotes next. That might make our life easier. So to find your asymptotes, you're going to set that y squared over 4 equal to that x squared over 49, which would give you that y squared equals 4 over 49 x squared. So your asymptotes are y would equal plus and minus 2 over 7x. So plus and minus 2/7 x are your slant asymptotes. So let's do the plus 2/7 x first. So at 1, it's about here. At 2, it's about here. At 3, it's about here. So it's really going to be a very low slope curve. And then let's see, -1 about -2/7, -2 about -4/7, -3, -6/7. Yeah, so there is your asymptote of plus 2/7 x. Let's find the minus 2/7 x asymptote. So at -1, you'll have about 2/7. -2, you'll have about 4/7. -3, you'll have about 6/7. All right. And then let's see, at 1 you would have about -2/7, 2 you'd have about -4/7, 3 -6/7, so alright, there's our asymptotes plotted. That's going to make our life easier if we do the asymptotes first. Now, let's next find our vertices. So x-axis is the major axis, so that means a squared equals 49, so a would have to equal plus and minus 7. And if the x-axis is your major axis, well, your vertices will then be plus and minus 7, 0. So 1, 2, 3, 4, 5, 6, 7. So there's -7, 0 all the way out here. 2, 3, 4, 5, 6, 7. Here's 7, 0 over here. So now since we got the vertices, we can draw the shape of this hyperbola. And then last but not least, let's go ahead and find the focus. So c squared equals a squared plus b squared. So that would have to mean then that would equal 49 plus 4, which means c squared equals 53. So c equals plus and minus the square root of 53. So your foci, since your x-axis is the major axis, your foci will be at the points plus and minus square root of 53, 0. So what is the square root of 53? I know it's a little over 7. I just want to see about where to put that. It's about 7.28. So somewhere in here for each of your foci. So now I've plotted the foci also, and we have a complete picture of what this hyperbola is going to look like. With the center at 0, 0, the x-axis being the major axis, and your vertices and your foci. All right. Now, let's say I give you this equation. So we have 25y squared minus 4x squared equals 100. So we have 25y squared minus 4x squared equals 100. Well, what's wrong with this picture? The right side equals a number other than 1. Remember when we did ellipses and we had to make the right side equal to 1? We got to do the same with hyperbolas. So we have to divide both sides by 100. If we do that, you'll end up getting y squared over 4 minus x squared over 25 equals 1. Now you have an equation of a hyperbola you can work with. So you have y squared over 4 minus x squared over 25 equals 1. So we got the hyperbola. Now, which axis is the major axis? The y comes first, so the y-axis is the major axis. So we have that much is clear. The y-axis is the major axis. Okay. Now, what's the center? 0, 0, as it will be for today's lesson, 0, 0. So let's go ahead and plot the center at 0, 0. Let's find the slant asymptotes. So to find your asymptotes, you would take that y squared over 4 equals x squared over 25. So y squared equals 4/25 x squared. So that means you have two slant asymptotes of y equals plus and minus 2/5 x. Those are your slant asymptotes, y equals plus and minus 2/5 x. So there's 2/5. We're going to do the plus 2/5 asymptote first. Alright, so let's go ahead and plot this asymptote. The plus 2/5 x. Now let's do the negative 2/5 x. So let's plot all those points. It can be a bit of plotting points here, but that's okay. So there's your asymptotes plotted. Okay. Now, y is your major axis, so that means a squared equals 4, which would have to mean a equals plus and minus 2. So your vertices, since your y-axis is your major axis, would be 0, plus and minus 2. So there's your first vertex at 0, 2, the second one at 0, negative 2. Okay. At this point, we have sufficient points to graph the shape of this hyperbola. A nice fat one. Those asymptotes help guide the shape of the curve, but we also need to find the foci. So c squared equals a squared plus b squared, which would end up being then that we would have 4 plus 25, which means c squared equals 29, so c equals plus and minus the square root of 29. So your foci are going to be at the points 0, plus and minus the square root of 29. So that's going to be a little over 5. Wow, yeah. That would be So here's 0 square root of 29. A little over that. So here would be 0 negative square root of 29. So there's your two foci. And then here's the shape of your hyperbola with center at 0, 0, and the y-axis being the major axis. One more graphing one, then yes, we're going to be given some characteristics of the hyperbola, and we got to find the the equation of it rather. All right. So we have 36x squared minus 10y squared equals 360. All right. So we have 36x squared minus 10y squared equals 360. Still the equation of a hyperbola, but the right side does not equal 1. It equals 360. So we have to go through, divide both sides by 360. If you do that, you'll end up getting x squared over 10 minus y squared over 36 equals 1. Now we have a form that we can work with for this hyperbola. X squared over 10 minus y squared over 36 equals 1. Alright, so let's go ahead here and first label our major axis. The x variable comes first, so the x-axis is the major axis. Alright. Now, what's your center? 0, 0. The center is at 0, 0. So let's go ahead and put that up here on the coordinate plane. 0, 0. Okay. Now let's find our asymptotes. So to find your asymptotes, that's going to be y squared over 36 equals x squared over 10. So y squared equals 36 over 10x squared. Wow, this is going to be a fun one. Huh. So you would get y tentatively equals plus and minus 6 over the square root of 10x. Which would equal plus and minus 6 times the square root of 10 over 10x. So this is going to reduce to y equals plus and minus 3 times the square root of 10 over 5 times x. So you have slant asymptotes at y equals plus and minus 3 times the square root of 10 all over 5 times x. Alright, so let's figure out what the heck that is here. So when x is 1, if we do the positive asymptote, that's about 1.89. So that would be about right there. So it looks like it's going to do this kind of number here. So if x is negative 1, it would have to be about negative 1.89. Okay. So there's the y equals plus 3 times the square root of 10 over 5 times x asymptote. which means when we negate this, negative 1.89 there, and then about 1.89 here. So all right, so there's our slant asymptotes. And the x-axis is the major axis. So that means a squared equals 10. So then a equals plus and minus the square root of 10. And since the x-axis is the major axis with center at 0, 0, your vertices will be plus and minus the square root of 10, 0. So square root of 10's a little more than 3. And then negative of that's a little less than negative 3. Since we have our vertices, we can actually go ahead and draw the shape of this thing. So there's the shapes of the hyperbolas, but last but not least, we got to find the foci. So that's going to be c squared equals a squared plus b squared, which would be then 10 plus 36. That means c squared equals 46. So c would have to equal plus and minus the square root of 46. So your foci, since x is the major axis, are going to be at both plus and minus the square root of 46, 0. Which would be a little less than 7. Yeah, there's your square root of 46, 0. That's a little less than 7. And then there's negative of the square root of 46, 0 right here. So there's your two foci with your hyperbolas. All right. So now we're going to be, this one's going to be pretty easy today. All right. So the center is going to be at 0, 0. So that's going to make life a lot easier. And we're done graphing for this lesson. But we're going to be given some characteristics of a hyperbola, and we got to find the equation. Alright, so for today's lesson, of course, the center's at 0, 0, which is going to help us. Now, what else do they give us? The foci are at 0, plus and minus 13. Your vertices are at 0, plus and minus 5. So here's the thing, right? We know the center is 0, 0, so whatever form this takes, it's going to be the variable minus 0 squared, which would just give you the variable squared, right? But in this case, you need to figure out which axis is the major axis, because the order of the variable does matter. Well, both your foci and your vertices have y-coordinates where your x-coordinate's 0, so that means your y-axis is your major axis. So you're going to have y squared over some number minus x squared over some number equal to 1. Because the center is at 0, 0, it's literally y minus 0 squared and x minus 0 squared, giving you that. Now, your vertices are based off the major length, right? So that means a equals 5, so a squared would equal 25. So you'll definitely have y squared over 25. That much is a given. Now, We don't know the length of the minor axis x. That's okay. What do we know? We know the foci are at 0, plus, and minus 13. That's a 13 unit change from the center, right? So c equals 13. That means that c squared equals 169. Now we can find the length of the minor axis if we take c squared, set that equal to a squared plus b squared. Well, that then would give you, of course, c squared is 169. That would equal 25 plus b squared, which would mean b squared equals 144. So the b squared's 144. So this equation you should get would end up being y squared over 25 minus x squared over 144 equals 1. So that wasn't so bad. In fact, for all the examples today, good news is they're just going to have foci and vertices. So that's not too terrible. All right. So center 0, 0. Foci at plus and minus 8, 0. Vertices are at plus and minus 6, 0. Alright, so the center's at 0, 0. Now your foci and vertices are on the x-axis because your y-coordinate stays 0, right? So the x-axis is the major axis, and the center's at 0, 0. That means you're going to have x squared over some number minus y squared over some number equals 1. Since the x-axis is the major axis, the x comes first. Now, your vertices are plus and minus 6. That's a difference of 6 from the center, right? So that means your a equals 6, so a squared would equal 36. And since x is your major axis, that 36 goes right below the x squared. So we have that. Now, we don't know the length of the minor axis. That's okay. We know the foci are plus and minus 8, which is a change of 8 from the center. So c equals 8. Well, that means that c squared would equal 64. Now we can find the length of the minor axis, or the b squared, if we take c squared equals a squared plus b squared, which means 64 equals 36 plus b squared. Whoa, I don't want to write 64 twice. We can't have a length of 0. I don't know what I was thinking there. So b squared would equal 28. So b squared is 28. That'll go right below your y squared. So the equation you should get for this would be x squared divided by 36 minus y squared over 28 equals 1. All right. Let's do 2 more. So you see, these aren't too bad today. Foci are going to be, again, at plus and minus 8, 0, with the center at 0, 0. But your vertices are different. They're going to be plus and minus 4 times the square root of 3, 0. Okay, so center at 0, 0 for this hyperbola, foci at plus and minus 8, 0, vertices at plus and minus 4 times the square root of 3, 0. Well, what axis is the major axis? Everything's on the x-axis since your y-coordinate doesn't change from 0. So the center's at 0, 0. This is clearly going to be x squared over some number minus y squared over some number equals 1. Now, your vertices are plus and minus 4 times the square root of 3. So that's a change of 4 times the square root of 3 units on the major axis. So A equals 4 times the square root of 3. That means A squared would equal 48. So that, since x is the major axis, that 48 goes below the x squared. Now, what else do we know? We know the foci, plus and minus 8, 0, that's a change of 8 units in each direction from the center. So your C equals 8, which means C squared equals 64. We don't know our B squared yet, but we can solve for that if we use the formula that C squared equals A squared plus B squared. So 64 equals 48 plus B squared, which would have to then mean that B squared equals 16. So that 16 would go below your Y squared. And the equation you should get is x squared divided by 48 minus y squared divided by 16 equals 1. And I got just one more, then we're done with the lesson. Center 0, 0. Foci are at 0 plus and minus 5 times the square root of 6. Your vertices are going to be at 0 plus and minus 4. Okay. So the center is at 0, 0. First establish which axis is the major axis. Notice for both your foci and your vertices, the x-coordinate of 0 doesn't change, but your y-coordinate changes. That means that your y-axis is your major axis. So the y variable will come first, and since the center is at 0, 0, you're then going to have y squared over some number minus x squared over some number is equal to 1. Now, to find our A, we know our vertices are 0 plus and minus 4. So that's a change of 4 units each direction from the center. So that means A equals 4. So A squared has to equal 16. So since the y-axis is the major axis, that 16 goes right below the y squared. Now, we know the foci are a change of plus and minus 5 times the square root of 6 units from 0. So C equals 5 times the square root of 6, which would have to mean then that C squared would equal 150. Alright, so we have that. Well, we don't know B squared yet, but that's okay. If we take C squared equals A squared plus B squared, this is going to turn into 150 equals 16 plus B squared, which would then have to mean that B squared equals 134. So that 134 would go below the x squared. So the equation you should get for this hyperbola is y squared over 16 minus x squared over 134 equals 1. So that's it for this lesson. Next lesson we will talk about hyperbolas where the center is not at the origin. So I hope everyone has a great day. Take care.